Hello, my name is Liang. I'll present my algorithm for CSC 575 workshop number 1 today. I'm not gonna describe all background information because of time limitation. Briefly, our task is design an algorithm which will correctly sort a special case list of n person in ascending order by friendliness scores. The only available function to call is meetup person A and person B. Assume the object person is given. If A and B are friendly to each other, the function will return true, otherwise return false. Here are several algorithm design bases. Firstly, meetup A and B equals to meetup B and A. So the sequence of A and B doesn't matter. Number 2, if meetup A and B returns true, then both A and B have friendliness score of n-1. So they're both friendly to everyone else. The third, if given A has friendliness score of n-1, first condition, if meetup A and B returns true, refer to the second one. B has friendliness score of n-1 as well. The second condition, if meetup A and B return false, then B has friendliness score of 0. So this one told me if I found unfriendly people with score n-1, if I call meetup with other people, I'll know the other people's friendliness score right away. I'll mention these later again. So based on this information and analysis, I came up with my algorithm here. I'll discuss it step by step. The function friendly sort has two parameters, P and N. P is a list of person object. For this special case, every person in P has friendliness score either 0 or n-1. N is an integer, size of P. The function returns a list of person, hopefully in ascending order, by friendliness score. So the major task here is somehow separating the person with score 0 and n-1. Firstly, we need at least 2 persons in P to call the meetup function. So if n is less than 2, we throw an exception message. The next step is finding the fourth pair of friendly person, Pi and Pj, by this nested loop to call meetup function. Meetup Pi and Pj, actually. A little trick here to optimize the cost is because I mentioned before, meetup A and B equals to meetup B and A. So if we call P1 and P2, we don't need to call P2 and P1 again. The int I will iterate from 0 to n-2. And the int j will iterate from I plus 1 to n-1. As this table shows, we just need to iterate this half. Now we introduce Q1 and Q2. Both Q1 and Q2 are list of person objects. Eventually, we will have all person with friendliness score 0 to Q1 and will copy all person with friendliness score n-1 to Q2. If meetup P1, Pi, and Pj return true, that means both Pi and Pj has friendliness score of n-1. They are both friendly to everyone else. So after we found this first pair, the iteration will be terminated. Then we'll copy Pi and Pj to Q2. Then we'll look at the the next step, we'll look at the index from P0 to I-1 and from I+1 to J-1. Because they return false when we call meetup function with either I, Pi, and Pj. So that means all of them must not be friendly with anyone else. So they should have friendliness score of 0. By this step, by this loop, I'll copy them to Q1. Now we'll look at this last portion of the list. Because we know Pi has friendliness score of n-1, so if we call Pi and J+1 all the way to n-1, by this loop, if it's returned true, that means this person has friendliness score of n-1 as well. We'll copy it to Q2. Otherwise, if return false, that means its friendliness score is 0, then we copy it to Q1. So after this step, we have copied everyone in P to either Q1 and Q2. This step, we just simply combine Q1 and Q2. We'll attach Q2 after Q1 and return. What if the whole iteration finished and no friendly pair was found? That means there is at most one friendly person in P. So either there's only 1 or 0. No friendly person at all. Unfortunately, by given information, we couldn't distinguish between these two cases, and we couldn't locate that only one friendly person in P. So for this case, we just return P at the end. Now I will use loop invariant method to prove the algorithm is correct. Initializations. P is a list of n-person objects. Before the first loop iteration, I equals to 0, j equals to 1. Q1 and Q2 are both empty. Maintenance. If meetup Pi and Pj return false, the loop will continue with the next iteration will either increase j or increase I if j already reached n-1, And Q1 and Q2 are still both empty. Then termination condition number 1. If meta pi and pj return true, the loop will meet termination condition. Then we'll do this bunch of operations and return. The termination condition number 2. If the whole nested loop is finished and termination 1 condition never happened, the loop will also be terminated and return. Now we'll look at the time complexity. For line 1 to line 4, just all of 1. For this nested loop, line 7 to 8, when I equals to 0, we'll iterate n minus 1 times. When I equals to 1, when I equals to 1, we'll iterate n minus 2 times. When I equals to n minus 2, we'll iterate just once. So the total cost will be like this. We will simplify it and got all of n squared. Once this condition return true, this line to 11 are all constant, all of 1. Then this for loop, line 13 to 15, iterates j minus 2 times. J is an integer between 0 and n, so we'll simplify it to all of n. The next for loop from line 17 to 24 will iterate n minus j plus 1 times. So simplify to all of n as well. The return steps will just all of 1. So overall, we have all of n squared, all of n, and all of 1. The total time complexity will be all of n squared, dominated by the nested loop here. Space complexity, line 1 to 3, just all of 1. This line, number 8, introduce I and j, still all of 1. The loop doesn't take actual space, just the constant space to store the result, and it can be reused, the space for every iterations. And these lines introduce Q2 with size 2. So constant, still all of 1. Line 13 introduce M, all of 1. Line 14, after this loop, Q1 size will become J minus 2. J is an integer between 0 to n, so this will take all of n space. Line 19, after this loop, the size of Q2 will increase half of n minus 1 minus j, so we'll take space all of n. The same thing with this loop. The size of Q1 will increase, so it's also take all of n. The return lines will be all of 1. So the total space complexity of this algorithm will be all of n. Now I'll look at the worst case example. The worst case happens when the whole nested loop doesn't terminate until both I and j reach the maximum number, which I equals to n minus 2 and j equals to n minus 1. The time complexity will be all of n squared. There are 2 conditions. The first one, if meetup Pn minus 2 and Pn minus 1 return true, which are the last two persons in the list. So the friendly pair found at the last iteration. Or the other condition is if the meetup of the last two persons return false, friendly pair not found at all. One example I'm showing here is all persons in P are not friendly to anyone else. Everyone has a friendly score of 0. So the person list P, everyone has 0 score. The whole loop iteration will happen like this and will take all of n square space. So if you look at this, the code, this part will be skipped. The whole iteration will finish and return. The best case example, the best case is all of n. The best case happens when the nested loop terminates after the fourth iteration, when I equal to 0 and j equals to 1. This type will be constant all of 1. If we call meetup of first two persons returns true, friendly pair found at the fourth iteration, then the next loop will happen. This one. Iterate n minus 2 times, which make the whole algorithm all of n. Example, the first and second person in P are both friendly to everyone else, with a friendly score of n minus 1. The other persons have friendliness score either 0 or n minus 1. This doesn't matter for this case. So we call the fourth iteration with 0 and 1 returns true, and the iteration terminates. Then the next loop will call 0 with 2, with 3, with all the way to n minus 1, n minus 2 times. It's all of n. Okay, this is my algorithm. Thank you.